Acceleration is the change of velocity per unit time. That is A equal to V minus U over T. A is acceleration, U is the initial velocity, V is the final velocity, and T is the time interval. Consider the motion along a straight line with motion towards the right as positive, with initial and final velocity becomes U and V. If a car starts from west and accelerates along a straight line with an acceleration of A equal to 3 meters per second square, that means the velocity of the car will increase by 3 meters per second When t is 0, v is 0, t is 1 second, v becomes 3 meters per second, t is 2 seconds, v becomes 6 meters per second, and when t is 3 seconds, v becomes 9 meters per second. When the velocity of a car increases from 5 meters per second to 15 meters per second in 4 seconds, we can say the car speeds up or accelerates, and the average acceleration of the car is A equal to V minus U over T, which is 15 minus 5 over 4, which is equal to 2.5 meters per second square. Consider another motion along a straight line. Let's take towards the right as positive again. If the velocity of a car decreases from 20 meters per second to 0 in a time interval of 5 seconds, we say the average acceleration of the car will become V minus U over T, which is 0 minus 20 over 5, which is equal to -4 meters per second square. The negative sign means that the car is slowing down or decelerate, 減速. Let's find the average accelerations of a body in the following questions. 1, 2, 3, 4. For 1, A equal to 10 minus 0 over 5, which is 2 meters per second square. That means it is accelerates. For the second questions, acceleration is 20 minus 0 over 5, which is 4 meters per second square, which means it has a greater accelerations than before. For number 3, the acceleration is 16 minus 4 over 3, which is equal to 4 meters per second square. Again, the acceleration is the same as number 2. For the last questions, accelerations becomes 2 minus 14 over 4, which is -3 meters per second square. The negative sign means that the body is deceleration. For a velocity time graph that we say VT graph, the slope of the VT graph represents the accelerations. Since A equal to V minus U over T, if the VT graph is the horizontal line, that means the slope equal to 0. We say that the acceleration of the body is 0. That means it is moving with uniform velocity, or we say it's moving with 0 acceleration. If the VT graph is a straight line with positive slope, we say the body is moving with a uniform acceleration. If the VT graph takes the shape of an increasing slope, we say the body is moving with an increasing acceleration. Again, the slope of VT graph represents accelerations because A equal to V minus over T. If the VT graph is a straight line with constant slope, but the slope is negative, then we say the accelerations is constant with a negative value. That means the body is moving with uniform deceleration. If the VT graph is a curve with increasing negative slope, then we say the body has an increasing negative acceleration. That means it is moving with increasing deceleration. Consider a body moving with uniform acceleration in a straight line. Take u, v be its initial and final velocity during the time interval t, and s be the displacement during this time interval. The VT graph will be a straight line because it is moving with uniform acceleration. The average velocity of the body will become u plus v over 2. Therefore, the displacement s will be equal to u plus v over 2 times t, which is equal to the area under the VT graph. Also, acceleration A equal to v minus u over t. By using equations 1 and 2, we can have two more equations, which is s equal to ut plus half at squared and v squared equal to u squared plus 2as. And equation 2, 3, and 4 are called free equations of motion. Case 1. From the VT graph, we have the equations v equal to u plus at. Therefore, we have u equal to 0, and the slope of the graph is equal to the acceleration. In the second graph, which is s against t squared, we have the equation s equal to ut plus half at squared. Again, we have u equal to 0, and the slope of the graph equal to a over 2. For graph 3, this is the graph of v squared against s, with the equation v squared equal to u squared plus 2as. Again, the initial velocity u equal to 0. Also, the slope of the graph will be equal to 2a. For the following uniform accelerated motion, complete the table. For case 1, we have v equal to u plus at. Therefore, v equal to 0 plus 2 times 6, which is equal to 12. By s equal to ut plus half at squared, we have s equal to 0 plus half times 2 times square of 6. Therefore, s equal to 36 meters. For number 2, again use v equal to u plus at. We have 30 equal to u plus 4 times 5. Therefore, u equal to 10 meters per second. Again, using s equal to ut plus half at squared, we have s equal to 10 times 5 plus half times 4 times square of 5. Therefore, s equal to 100 meters. For number 3, v equal to u plus at, we have 28 equal to 4 plus 3 times t. Therefore, t equal to 8 seconds. Again, v squared equal to u squared plus 2as. Therefore, we have square of 28 equal to square of 4 plus 2 times 3 times s. Therefore, s equal to 128 meters. Number 4 and number 5 will be left for you to do using the similar methods.